Hi everybody. We are on our day one of trigonometry. So like I said, this whole chapter has been finding missing sides or angles on right triangles, right? That's the whole purpose of this chapter. So now we're kind of getting into the heart and soul of it, trigonometry. Now trigonometry is used specifically to find missing side lengths and angles of right triangle. Um, what is trigonometry? A quick definition, it's just the study of triangle measures. We just hardly scratch the surface of what we can do with trig in our class, but this is used all over in aviation or engineering, in NASA. I can't even begin to tell you. It's very applicable, and unfortunately, like I said, we just scratched the surface of the very, very basics of what you can do with trig. Um, but it is very applicable in the real world, especially those of you that plan to go to a post-secondary school. Like you will use trig in most of the fields that you go into, okay? So let's just get into it. What is trigonometry? So trigonometry has three ratios. Now remember, a ratio is just comparing two numbers, a number over a number, right? That is all a ratio is. Now with trig, we have specific ratios, okay? So now the first one is sine. Yep, this looks like right here, sine. That's how you say it, sine. Now the sine of a specific angle is its opposite leg over its hypotenuse. So that's why I highlighted these two words here. Sine is your opposite over hypotenuse. So if we look down here, and I'm kind of jumping all over, this is on the right side of your paper. It's a sine of angle A. Well, we're going to mark angle A because that's our reference angle. That is telling us what angle we're going from. Now from here, we have three different legs. Let's do the most obvious one. Your hypotenuse is across from the right angle. So I'm going to write hypotenuse, height. That's my height. Now your side opposite your angle is across from your angle. It's through your triangle. So that would be A. That's your opposite. And then your adjacent is your side that's not your hypotenuse, but it's right next to your angle. So that's your adjacent, okay? So that's how you start every problem. You list or label all three of your sides. Now from here, folks, we can write our ratios. So like I said, the sine of angle A is our opposite over hypotenuse. So if we look here, our opposite leg is A, our hypotenuse is C. That is the sine ratio from angle A. Now our cosine of angle A is the adjacent leg over the hypotenuse. So when we look over here, what did we label as our adjacent? Well, that would be angle or side B. Our hypotenuse is C. So your ratio for the cosine of angle A is B over C. Now your last one is the tangent. Now the tangent of an angle is its opposite leg over its adjacent. So again, go back to what we labeled. Our opposite leg is A. Our adjacent leg is B. So again, I know when we kind of just talk about the formulas, things are confusing. The key thing that you need to take away here is that your sine is your opposite over hypotenuse. Your cosine, adjacent over hypotenuse, and your tangent is the opposite leg over adjacent. Now, an easy way to remember this is a mnemonic device called SOHCAHTOA. SOHCAHTOA. So sine, you guys see how it starts with an S? For sine is your opposite leg over the hypotenuse. That's your sine. Your cosine for ka is your adjacent leg over hypotenuse. And then lastly, toa for tangent, T for toa is your opposite leg over adjacent. Okay? So SOHCAHTOA is a really good thing to write on the top of your paper or your test because it will help you remember which legs go with what ratio. So if we try this first one out here, it says give each trig ratio as a simplified ratio. So that's a key thing there, folks, is you always want to reduce, okay? You always reduce. So let's start here. So it says sine of angle A. So remember, step one is mark your reference angle, and that's the letter that's given right after your trig ratio. So I marked angle A, and now we're gonna list our three sides. So again, your hypotenuse is always across from the right angle. Your adjacent leg is right next to your angle, and your opposite is through your triangle on the way other side of your triangle. Okay? So now that we've listed our three trig ratios, I'm going to write SOHCAHTOA here so we can see it. Now we can write our ratio. So sine, opposite over hypotenuse. So I look what I labeled as my opposite was 5. Our hypotenuse is 13. Now check. Can we reduce 5 over 13? Nope. So that's a good answer. We're done. Try the next one. Cosine of angle A. Cosine is adjacent over hypotenuse. Our adjacent leg is 12. Our hypotenuse is 13. Can we reduce 12 over 13? No, we can't. Not today anyway, so that one's also a done answer. Now your tangent is your opposite over adjacent. Our opposite is 5. Our adjacent leg is 12. That's it. We wrote our ratios. Okay, so now I'm going to erase just a little bit here. Because now on these three, we are going from angle C. So that's going to change things a bit. So now we have C as our reference angle. I want you to pause the video and to label your three sides of your triangle from angle C and list your three ratios. Okay, and then you can compare with me. But right now, label the three sides of your triangle and write out your three ratios. All right, so I'm going to label now my three sides with respect to angle C. My hypotenuse is always across from that right angle. My opposite side is always on the other side of my angle. And then your adjacent side is connected to your angle. All right? Now from here, sine is opposite over hypotenuse, so you should have had 12 over 13. We can't reduce, so we're done. Cosine, adjacent over hypotenuse, so 5 over 13. And then the tangent is your opposite over adjacent, so 12 over 5. Now, folks, remember, these are just some numbers, right? You can type in your calculator 5 divided by 12, and it's going to be something less than 0.5, right? So, I mean, it's going to be less than that. Remember, these are just some random decimal number. And someone a long, long time ago programmed your calculator into figuring out what these were so we didn't have to, okay? So just remember that's all you're doing. You're just writing ratios of your side links. But now we're going to actually find missing side links, and I'm going to switch over to my doc cam so you can see how this will look, hopefully. Okay. All right. So now we should be here, right, children, folks, I suppose. I can zoom in a bit. Bear with me real quick here, kids. Oh, yeah, that's great. This is what we want. Okay, so I'm going to write SOHCAHTOA right here so we can see it. And now we're going to solve for missing side lengths, okay? So the process starts off very similar, you guys. You're only going to be given one angle measure. So start off by marking that angle. That's our reference angle. And now you're only going to label the two sides that you're given. So if I look here, what's x with respect to this angle? Well, that's on my opposite side. So I'm going to put opposite. And 19's across from that right angle, so that's my hypotenuse. And do you guys see how we don't have anything right here? So I'm not even going to list this is my adjacent side because that's just going to make me more confused. So right now we only know something about our opposite and hypotenuse. So if I look here, what trig function deals with the opposite and hypotenuse? Well, that's our sine, right? OH is opposite hypotenuse. So now we're just going to write this out. So we're going to write sine, S-I-N is how we abbreviate it, of our angle, which is 28. is equal to x over 19 because it's opposite over hypotenuse. Now, I know this looks really confusing, but it's honestly not. Because remember, you guys, sine of 28, like I said before, someone a long time ago programmed our calculators with all these trig functions so we didn't have to. This is just some ratio. This is just some number. Like if you could type in sine of 28, it's just the ratio of those two sides, but in a nicer form so we don't have this long decimal. That's all this is some random number. So if we're looking for x, I'm going to move my calculator real quick. We have to get x by itself, right? So how do I get rid of divide by 19? Well, of course, we have to multiply by 19, okay? So now you're going to have 19 times the sine of 28 equals x. Now, folks, that's just calculator work. So in your calculator, you're going to hit 19 times, now that sine button, you guys see that? How you've probably seen these trig buttons and never really knew what they were for? Well, now we're going to use them. So sine of 28 equals. So that side length should be 8.9. And there you go. We just found it. 8.9 equals x. So you will definitely need a calculator to do this because obviously you don't know these trig ratios in your head, right? I mean, it'd be incredible if you did. But you can use your phone. I have an Apple or iPhone, excuse me. If you turn it to its side like this, you should be able to figure it will turn into like a scientific calculator like that, but you have to do it backwards. So on like a phone, you would hit 28 and then the sine button. So there's our ratio times 19. So then I get that 8.9, which is what we wanted. So when you do it in your phone, at least with an iPhone, you kind of have to type it in backwards, otherwise it won't compute it correctly. Okay? Let's try another one. So again, how do we start? We start by marking the angle we're given, so 55. Now label our sides. Okay, x is across, right? So that's our opposite. 8 is touching it, so it's our adjacent. And we don't know anything about our hypotenuse, so I'm not going to label it. So we're just done there. So now we look up here. What trig function uses opposite and adjacent? Well, that's our tangent. Excuse me. So we're going to write the tangent of our angle equals x over 8, our opposite over adjacent. Okay, remember folks, tangent of 55, that's a ratio. You can just type that in your calculator, so it's just some number. How do we get x alone? Well, multiply both sides by 8. There we go. So now we're going to have 8 times the tangent of 55 equals x. So again, grab your calculator, shimmy this over. We're going to type in 8 times tangent of 55. And we should get 11.4. You guys with me? Did you get 11.4? If you're going to be a phone user, let's just practice one more like that together, okay? So again, turn your phone on its side. There we go. So you type it in backwards. So you type in 55 tangent, so there's our ratio, times 8 to get that 11.4. Beautiful. All right, children, one more. Okay, so again, we start off by marking our angle, which is 27. Label our sides. X is across from that right angle, therefore it's our hypotenuse. And let's see here, 5 is across from our angle, so that's our opposite. So we're looking, our opposite hypotenuse combo, what is that? OH would be our sine, right? So we're going to have sine of 27 equals our opposite 5 over hypotenuse of x. Okay, so we haven't come across one yet where our variables in the denominator. Don't let that freak you out. You guys know how to do this. So how would you get rid of divide by x? You would simply multiply both sides by x. Okay, so on the left side, you're going to have x times the sine of 27 equals, those x's would cancel, so it just equals 5. And then remember, you guys, if you can multiply by the sine of 27, you can also divide by it, right? So how do you undo multiply? We divide. Yep. So divide both sides by sine of 27 degrees. The left side, those are just going to cancel away. So you're just going to be left with x. And now in your calculator, we got to type it in. 5 divided by the sine of 27. 11.01 is just 11. Does that work, folks? Just 11. There we go. Perfect. Good job. I realize I'm not with you today, so if you're a little lost, try your best with the homework, and we'll go from there. But let's try these bottom three real quick. I'm going to go back to the smartboard, though, because I think it's a little easier to see. Okay, so we should be on these last three. So now we're going to incorporate, you guys, our special right triangles with our trig. So I know I don't give you a ton of room, but somewhere towards the bottom, let's make our special right triangles. So let's start with our 45, 45, 90. So here's our 45, 45, 90, right? Now, the smallest whole number sides you could have would be 1, right? So that would be a 1, and that would be a 1. So those are the same. And then think about it, folks. How do you go from your leg to your hypotenuse? You multiply your leg by the square root of 2. So really, it's 1 times the square root of 2. Or if you just want to be simple, we don't even need that 1 there. So we can just have square root of 2. Okay, so that's the simplest 45, 45 right triangle you could have. Now let's draw in our 30, 60, 90. Okay, what's your smallest short side it could be? Well, 1, right? Now how do you go from your short side to your hypotenuse? We double it, so it would be 2. And now to get your long leg, you take your short times root 3, which we know would just be root 3. So please make sure you get those down in your notes, because that's how you're going to answer these next 3 questions. So if we want to find the sine of 30, I obviously know I'm going to be using this triangle here. So remember, sine is opposite over hypotenuse. So if I label here, my opposite from 30 would be 1. Your hypotenuse would be 2. So if we label that, it would just be 1 over 2. That's it. We got it. Okay. Cosine of 45. I realize I have to use the 45, 45, 90 triangle. It doesn't matter. You're going to get the same answer. So just pick whatever angle speaks to you. I'll stick to the top one. Cosine is adjacent over hypotenuse. So your adjacent leg is 1. Your hypotenuse is root 2. So we're going to have 1 over root 2. However, if we learned anything the week before spring break is we know we can't have a radical in the denominator. So we have to multiply by that special version of 1. So on the top, we're going to have root 2. Root 2 times root 2 is root 4. The square root of 4 is 2. So your final answer there would be root 2 over 2. And then our last one here is tangent of 60. So let's see here. Let's use black. Okay, so tangent we know is opposite over adjacent. Mark 60. Our opposite would be root 3. Our adjacent is 1. So we're going to have root 3 over 1. You can leave it like this, or if you want to be more simple, root 3. Woof that. All right, folks, you have an Alex assignment. Help each other out. Tomorrow we'll answer any questions that you have. Thank you for watching this video lesson, and I will see you tomorrow. Goodbye.